Well, let's do 16, 17, 18, no, 16 through 20. I guess I'll go to this view. Okay, 16 through 20. Okay, this is the next block. 16, the state functions path independent. And we have beat that particular horse to absolute death. We showed it with the Joule cycle once again, but we actually used it to find out what are state functions as well, or something characteristic of state functions, and this is absolutely true. I can't say any more about it. I could, but we beat it to death already. So 17, the energy of a system is distributed equally
In all directions.
to every degree of freedom available to the molecules of the, which is a very long-worded question, but I've just described a thing that's called, that has a name. What is this a statement? What is the statement called?
Is it equipartition?
Yep. Equal partition of energy, which means that the energy is distributed equally. And for each degree of freedom corresponds to, if there is a type of energy, there's a corresponding degree of freedom. And so there are two basic types of energy, kinetic and potential. And for the kinetic energy, we can decompose that to three possible directions that are, we have in three-dimensional space, we can move in three different directions. And there is no favored degree of freedom. If there was, then the gas in this particular container, the molecules could all be heading up, and we'd see them Wingardium Leviosa. And we don't see that. So this is just a statement of what we've observed our whole lives, and a lot of the physical laws are just statements of what we've observed that know no exception. So at thermal equilibrium in particular, equipartition of energy exists. The energy is distributed equally to all the degrees of freedom, and this is very true. That's equipartition of energy. Number 18 is work is a state function.
No.
Yeah. And we pretty much beat that horse to death too.
It's path dependent.
So yeah, this is a path-dependent thing, which is a good thing, which means our cars will get work done.
Yeah.
Every cycle, the energy's zero, but there's heat, as can be verified by anybody who wants to lick the manifold of their engine after it's been running. And there is work done because our cars, when they're working, get us from point A to point B. So this is false. Now, 19, which is delta G is the maximum work available from the process. Okay, now this again, we have pretty much, that was with the course and the process, the course that we followed from the very beginning when we were discussing the multi-stages
Right.
of that Boyle's law expansion, the isothermal expansion. We found the maximum work.
Right.
And that led us to the Joule cycle, where we found the Q and W are equal and opposite, and our goal all along was to find the maximum work. And that ultimately led us through the second law to the
Gibbs
Gibbs free energy. The Gibbs free energy is
Yes.
the maximum work available for any process. So this is true. Now we're at 20. And that one is the minimum theoretical limit to the entropy of it should be the change in entropy, would be a little more rigorous, of a process is Q over T. And is this true? Or, no,
Temperature.
T is temperature. And what I wanted to recall that, and this was from Carnot's work,
Right.
he discovered there was this new state function called entropy, which he found was equal to the Q reversible over the temperature. So the equality applies only for the reversible process, which sets a minimum theoretical limit because we can never have a truly reversible process, and led us to the inequality of Clausius, which is a statement of the second law of thermodynamics, that delta S is greater than Q over T for every process, because no process is reversible. So the equality suggests that this would only apply in an unattainable set of conditions. This means that the entropy of the universe is continuously increasing, because it
Right.
always exceeds this minimum value. And this is actually the best statement of the second law of thermodynamics, is the inequality, it's called the inequality of Clausius, after Rudolf Clausius, the
So we're
theoretician
going down.
who developed it. And so that wraps 16 through 20. Oh wait, is this true? Yes.
Yes.
So that is true. Now, okay.